Hello everyone and welcome. Today we will be building a workflow using HashiCorp Vault, Terraform and AWS. So let's dive in. First, the agenda. We have Terraform. Terraform is an IAC tool. IAC meaning infrastructure as code. What it does is that you write code in Terraform and it converts that code into infrastructure. Now, what is infrastructure? Let's say I have AWS and here I want to build S3, EC2, and whatever else. Okay, so what you do is that you write your code in Terraform and it builds these S3, EC2, etc. in your AWS account. This is called IAC, that is infrastructure as code. Now, the thing is, Terraform can't just go into AWS and build this infrastructure, right? It has to know which is your account, right? And how one can know your account? By username and password, right? So you need some credentials. Terraform has to have some credentials in order to have the right AWS account, right? Yes. But if you write those credentials in Terraform code, is it a good practice? Obviously not. If you write it manually, hard-coded, and if you share that code with someone else, he will get your credentials to your AWS account. So obviously it's not safe. That's why we use something called HashiCorp Vault. Like the name, it is what it is. It's a secret management vault. Okay, where you can put all of your secrets and manage them properly with full security. Now, if you don't know what is Vault, I just give you a quick brief about it. So, Vault. So, as I mentioned, it's a secret management tool by HashiCorp, the same company as Terraform. But why is it preferred? First one is that it is centralized. Okay, it is centralized. Like if you have, let's say, if you have database, if you have AWS or other cloud, you might also have many other secrets. For everything, you have a centralized location where you put your secrets there, and it is safe. That's why it's so famous. Okay, it's safe. So it is centralized. You don't have to remember your credentials for database separately, AWS separately, secrets separately. No, you put it in one place where you will find all of your secrets and it will be safe. That's the main point. Okay. The second thing is that there are some security measures like authentication. Auth. Okay. You can't just go into Vault and see the secrets and credentials. You need to have valid authentication, and Vault has lots of authentication. If I go to the documentation, let me show you, where is it? Yeah, so if you scroll down, and yeah, auth and methods, you'll see there are lots of options here: AWS, Azure, GitHub, Kubernetes, LDAP, etc. So there are lots of options, even username and password if you want. So not everyone can get access to Vault and see your stuffs. Okay. Upon that, you have policies. Okay. You have authentication, you have entered into the Vault, but you can't see everything. There is a set policy that what you can do and what you can't do. So you're being restricted to know the specific secrets. This is a huge thing in terms of privacy or governance or security. Okay, Vault offers you that. And another thing about Vault is you can audit. You can see who has access to your secrets, how many times, and who. So it's a really important thing. Another feature of it is EAC. That means encryption as code. Okay, we're not going to deep dive on this one, but in vague terms, it means you can encrypt and decrypt data by using Vault. Okay, so these are the core features of Vault. There are some other features for which it is so popular, but the feature that is most relevant to our session today is that Vault can store static data as well as dynamic secrets. Okay, now what do I mean by static secrets or static data? It means if you store A in your Vault, after storing, if you read it, you will see it is A. Nothing changed. It is what it is. Okay, that is static. And dynamic secrets means, let's say you have stored A, okay, but you don't want anyone to know that. Okay, so what Vault can do is that it can generate new secrets after a certain time. Let's say from A it generated B, which will be available for only 5 minutes. After that 5 minutes, if you input B in your, let's say, password, it won't work, because after 5 minutes Vault will create a new password C. Okay, and in that 5 minutes you have to put in C as password. So you see the dynamic rotation, the word rotation. Okay, this ensures a greater security. Okay, if someone just knows your passwords or secrets, it doesn't ensure that you will be hacked. Okay, because it is continuously rotating. Clear? Okay, fine. So this is the static and dynamic secret. So these are the main features or reasons why Vault is used as key secret management tool. So let's get back to our agenda. Yes. So what we are going to do today is that instead of manually hard coding the credentials in Terraform script, we are going to store our credentials in Vault. Okay? And when Terraform asks, the Vault will return the secrets or credentials to it. And finally, Terraform would be able to create the infrastructure in AWS. Clear? Okay. Now, let's go a bit deeper. Let's say AWS is going to give the credentials of IAM user. So what's the credentials for IAM user? That is secret key and the access key. Okay? Okay. So what we are saying is that first you will store the secret key and access key in the Vault, and it will be stored there. Now you might ask a question that eventually I'm giving my credential and secrets to Vault. So I'm giving it to someone. Is it safe? Yes, it is safe, because this secret that you will be giving, the root secrets or the root configurations, will be only available to you, no one else. Without the root permissibility or root power, you can't see these secrets directly. Okay, no one else. So it is only for you. Okay, now when Terraform asks, it in return gives some secrets, and in our case for today's discussion we will be using dynamic secrets. Okay, so again the flow is Vault will store the credentials in Vault, and whenever Terraform asks, it will return some credentials, but it would be dynamic credentials. Okay, fine. So the next thing, in Vault there are a few types of credentials, or there are certain ways where you can handle this part, from storing the data and to giving it to someone. In our case, Terraform, there are some types for it. Okay, let me show you in the documentation itself. So let's go to the documentation, and okay, let me directly search it. Assume role in HashiCorp Vault. Okay, introduction to roles, and let's go here. Yeah, so sorry, my bad, it's in secret engine, so just search Vault AWS secret engines and you will find this one. Okay, here you can see Vault supports 4 different types of credentials to retrieve from AWS since we are using AWS. So as you can see, the first one is IAM user, second option is assumed role, the third one federation token, and the fourth one is session token. Okay, now in the documentation, as I have seen, they have clearly mentioned the steps for IAM user. Okay, but the rest are not so clear. For today's session, we will be showing you assumed role since it is the most widely used. Okay, so we will be dealing with this one. So let's go again to our notebook. What does this assume role credential type actually mean? So the title would be assume role. Assume role. What it means is that, let's say we have the AWS here and we have Vault here as before and Terraform. As I've mentioned, we will be storing the secret key and access key of an IAM user in the Vault. But in assume role, what else we are going to store is called role, IAM role. I hope you are familiar with that. So we are going to input 2 things, secret key and access key for the IAM user and a role. And we're going to store it in Vault. In return, as I have mentioned, we will give dynamic keys, dynamic secrets. Okay. Now, why this assume role? This part, the secret and access keys, are used for accessing AWS. Vault itself needs an access in the AWS. So Vault will use these two and access the AWS. And when Terraform asks for credentials, it will return dynamic secrets which will grant him permissions of this role. Let me again clarify. So these two, meaning secret key and access key, is giving access to AWS for Vault, and this role is basically giving the what permissions part, what permissions or what it can do. Clear? So whenever Terraform asks Vault, it returns dynamic keys, and Terraform gets the power of this role. So in vague terms, we can write that dynamic key here or dynamic secrets means power of the role. Okay, power of the role. When the Terraform receives these keys, now it has the power of this role. It can do whatever this role can do. Clear? And this is our assume role. Assume role. Why it is assume role? Because Terraform is assuming that it has this power of this role. Okay, it is not creating the role, it is not creating any separate IAM user, rather Vault is giving the access of using this role. I hope I'm clear. So this is the theory behind assumed role. Okay, fine. So now for the next part, let's go to the hands-on. So let's give the title hands-on. First, what we have to do is that set up an IAM user. Okay, so let's go to the console. Let it load. Yeah, so we are going to create a new user. Let's go to the users, create user. Let's give it a name, what? Vault demo. Click on this. Yes, I want to create an IAM user. Custom password. I click this one. I'm setting as my wish. You can do whatever you like. Click on next. And for the time being, let's not give any permissions. Okay, click on next. I'm not giving any permissions to it, no resource, and create user. So we have created the user successfully. Return to the list. I don't need to download that part. So yeah, so as you can see, we have a new IAM user created. So we are done with the IAM user first step. What's the second step? We have to create the IAM role. IAM role. Okay, so let's go to the console again, and let's go to the roles, and let's create a role. Okay, there are multiple ways of doing this, but I'm showing you this one. To point to be noted is that we are going to create S3 bucket. Okay, what I am meaning is that in our workflow in this one, the infrastructure we are going to create is a S3 bucket. Okay, nothing too complex, a simple S3 bucket. That's why in this one we are going to use S3. Okay, use case, service, or use case, we have selected S3. So click on next. And for the time being, no, we can do this here also. S3 full access, you can restrict if you want, but for the demo purpose I'm giving the full access. And let's give the name Vault demo. I've also given the same name for the user as well. So yeah, everything's fine. And create a role. So the role is also created here. So let's go to the role and you'll see it has been created. Up until now we have not attached any permissions in the user. Let me show you. Let me refresh first. Yeah, so Vault demo is our new user created, and as you can see there's no policy attached. Let it load. Yeah, no resources to display. But in the role, since we are going to create S3 bucket, we need S3 permissions, and for the demo purpose I have given the full access. Now we have done the second part as well, the second step. What's next? Next, what we have to do is that we have to make connection between these two, IAM user and IAM role. Okay, what I mean is that create connection between this and this. How we are going to make this handshake happen? We're going to make it happen through something called ARN, that is Amazon Resource Name. Okay, if you go to the policy or username, here you can see ARN. See this? Similarly, if you go to the Vault demo, this one. Here you can also see the ARN. Clear? Okay. So as I mentioned, we're going to do this handshaking using ARN. How? Let's go. First, let's go to the role. Yeah. And click on trust relationship. This is very important. What it is saying is that I am a role and I trust this. Okay. And if it asks something from me, I will give it to him. Okay. This is basically the trust policy or trust relationship. Click on edit trust policy, and here what you have to do is search IAM, because we are going to attach an IAM role here. Oh, sorry, all actions. First, all actions, because we're making it very vague. Okay, so we're giving all access. You can restrict if you want. We don't need everything. We just need, I guess, assume role. That's it. We won't be needing anything else, but for the demo purpose, just keep everything. Add, and here click IAM roles, sorry, IAM user, since we are doing the role one first. Okay, what I'm meaning is that we have the role, we have the user. What I'm doing now is that creating this connection. The role is getting connected with the user. So principal type here, select IAM user and this ARN. Here you have to put in the ARN of the user that we have created. So get back to Vault demo user, click on this, and it is being copied. Return to this one and paste it. Okay, fine. And add principal. So if you scroll back, here you can see that we have our Vault demo, this one. Our user Vault demo is now a trusted entity in the trust relationship. Clear? What it means again is that the role has trusted our user. Now if the user asks the role anything, the role will say, yes, I know this guy, he is a trusted person, he is quite honest, so I will help him. Clear? Okay, so we have done this part. Now what we have to do, it's a two-way handshake, as you can see here. So we have done this one. Now we have to do this. User has to ask the role. Role is ready to give whatever benefit the user needs, but user has to ask it. So we have to create that bridge. So let's go to the user part, and as I previously mentioned, we haven't added any policy, so we have to do it now. Create inline policy, and click on JSON. Okay, yeah, it's loaded. And here in this resource, you just need to paste the ARN of the role. Okay, we can do it from here as well. What we have to do is click on IAM role, and click on add resource, and it should be here. Let me see. So why isn't it here? Okay, let me, I think I have, I think it's IAM, not IAM role, I think. Yeah, let's see the resource now. Add resource, click on service. IAM now should be roles here. Yeah, role. Yeah, I think, yeah, it should be IAM. So again, let's go to the Vault demo role and copy the ARN from the role and get back to the user one and paste it here. What we have done is very simple. Okay, as you can see, the resource role has been added. Clear? Okay, fine. So what we have done is that we have made the handshake. We have made the handshake between the role and user using ARN. We just put the ARN of user in role and the ARN of role in the user and created this handshake. Okay, now we are clear that if user asks the role for any help, the role will notice the user as it is in the trust relationship and it will provide the necessary credentials. Clear? Okay. Now the third step. The third step is Vault setup. And for this demo, I'm assuming you have Vault and Terraform already installed in your machine. Okay. So let me go to my VS Code. Let's open up the terminal. Yeah, where's the terminal? Yeah. Let me open Ubuntu. You can do it in PowerShell, but Ubuntu is better. Let it load. So my VS Code is loaded, and let me show you. I have already installed Vault. So Vault version. Yeah, it's taking a bit of time. Similarly for Terraform version. So fine. So I have both Vault and Terraform installed in my machine. So do that first, and after that, the next step. What's the next step? Vault setup. We have to initialize the Vault server. So in this, I have something to say. In Vault, we have some layers. First of all, you have to unseal it. Unseal the Vault. Okay. After that, you have to authenticate. And after the authentication, you can get the secrets. You just can't get the secrets. It has to be according to the policy. Clear? So these are the layers. Okay. But for this demo purpose, we are not going to do this unsealing part. We are not even going to do this authentication part. And since we are not going to do this authentication part, policy is also deducted. So for this session, our only focus is these secrets, how to store secrets and how to get secrets, and we'll be using dynamic secrets for this. Okay, so again, we are not going to do the unsealing part, we are not going to do authentication or policy. Disclaimer is that since we are using a machine, not a human authentication, because Terraform is going to authenticate, not any human. That's why we can use something called app role. It's an authentication method. If you go to the documentation, you will find it. Okay, for any machine authentication, you can use app role. And since we are not going to do that here, we are going to use admin or root access. Okay, so for the demo purpose, we are going to use the dev environment, not the production one, and we are going to use the root credentials or the root tokens for the authentication and etc features. Okay, fine. But I'm going to make a future video on April, so stay tuned. So let's go to the VS Code again and just type in Vault server dash dev. Okay, and enter. It might take, yeah, this one was fast. Yes, so our server is on. A disclaimer here as well is that don't shut this running command, because if you shut it down, your Vault server is also going to be shut down. Instead, what you should do is that create another terminal here. Okay, keep that one running and create a new one. Clear? Okay, after you have done the Vault server, let me also write it here so for reference. So first one what we have did is that server dev. After that, what we need to do is create the environment variables. Okay, the environment variables. What environment variables? If you again go to the previous section of the terminal, you'll see that there's this command here. There's something to copy paste. You may need to set the following environment variables. What it is doing is that it is creating a address in our local machine, in the local host of port 8200, where we can access the UI of the Vault. Okay, Vault has also the UI, but we're not going to deal with the UI, but you have to export this one. So what you can do is that copy the entire thing, copy, and go to the other terminal section and paste it and enter. Clear? Okay, now do Vault status to make sure it is running fine. Let's see. Yes, so our Vault server is active. We have initialized the environment variables, and it is showing that seal type Shamir. It's a algorithm for the sealing, but since we are using the dev mode, it is auto unsealed. As you can see, seal is false, auto unsealed, so no need to worry about that. So yeah, our Vault server is ready and active. Now for the next part is that another thing I should show you before that, that is root token. So again, if you go back to the other section, you'd see these two. You can practice this unsealing using this unsealing key, but we are not going to do that, but we will be using this root token. So let me show you. Copy this one and go to login. It is not necessary. Okay, we are already logged in as the root user. You don't need to do this, but still I'm just showing to you. Vote login and paste the root token and enter, and you will see some data regarding this root token. As you can see, the token duration is infinity, meaning it will not expire ever. It's here to stay. And the policy is root, meaning it can do anything you want, anything. Clear? Okay, so yes, up until now we are done with the Vault setup as well. So we have done the IAM user part, the IAM role part, and the Vault setup. What's next? The next part is we have to create the Vault secret engine. Vault secret engine is basically something that helps us to manage secrets, storing secrets, managing secrets, getting the secrets from it. Everything is managed by the secret engine. As I previously shown, let me again go to the documentation. Where is it? Yeah, let's go to the secrets engine. It should be, yeah, there are lots of secrets engine, as you can see. AWS, Azure console, databases, yeah, lots of options to pick from. So since we are using AWS, so our secret engine would be AWS. Clear? So let's enable that. First, let's clear the interface, yeah, and run this command: Vault secret enable AWS. You can also mention the path here. If you don't select that, it will be automatic to AWS. Okay, clear? Okay, and press enter. Okay, is there any error? Vault, I guess it should be secrets. Let's see, I think I missed an S here. Too many, whatever. Wait, I think the AWS portion is the last bit. Yeah, Yeah, I mentioned the AWS part, meaning the engine name in the before the path. You can skip the path. If you skip the path, then the AWS, the default path would be AWS. Okay, so no need to worry about that. Okay, fine. So we have initiated the Vault secret engine. If you want to see it, Vault secrets list, and it will show you. Here you go. We have a secret engine here. As you can see, the type is AWS, the path is AWS. There's an accessor address as well, but there ain't any secrets here because we haven't created them. So the next step is creating Vault root configurations. Let's dive in. For this one, what we will do is that write Vault write AWS config/root. Okay, and yeah, I can copy paste. So I can also take that code from here, from the documentation. As you can see, where is it? Yeah, this one. So let's go to the VS Code. We can just copy paste it. Sorry, clear. So let's just copy paste this, and we are going to be using region app south, and the secret key. The secret key of what? The user, the IAM user, which is for us in this demo is this Vault demo. So let's go to this one, and how you can. Okay, I think I haven't saved this one, have I? Yeah, I have forgot to save this one, so let's save this. Next, create policy. Oh, there's a name, so let's also give it Vault demo and create policy. So yeah, if you just got stuck, what I did is that I created this handshake, that is role and user handshake, but in the role user part I mentioned the role ARN but forgot to confirm it, uh, so I just did this. So let's get back to it, and now I am in my user, that is Vault demo, and how to get the access key and the secret key. Click on this one, create access key, click on CLI, we're going to use that. Click on this and next. I don't need any tag for now, and click on download CSV file. It will I think it's only available one time to download, so mind that, and open file. It should open up the file in your VS Code. So let's see. Yeah, so it has opened. Let me scroll this one down. Yeah, so I'm showing you the access key and the secret key of my user, because I'm going to delete it right after I am done with this demo. So nothing to worry, no need to worry about hacking. So in the X secret key, let me just paste this one. So very careful about this, because if you copy any space, it will show error. Okay, so mindful of that one. And yeah, go to the access key part and copy the access key from here and paste it here. Clear? Okay. Additionally, you can also put apostrophe, the quotations here, just to be safe. Okay, sometimes what happens is that we tend to forget to do this, and sometimes the spaces after uh, the actual credential get involved. You see this space, so be very careful. It works without the quotations, but sometimes you might make mistake. That's why it's better to be alert. Okay, so yeah, we're done with the vault write AWS config root. Another thing to be noticed is that this thing that you see, AWS config root, it is fixed. It's a fixed path. You have to do it. There's no alternative to it, and you have to keep this exact path. Okay, so after that we have inputted just the access key and the secret key and the region for our actual user, in our case, which is this one, Vault demo. Clear? Yes. And now press enter. Hope to see a successful message. Okay, success, data returned to the root. Okay, fine. So we are done with this step as well, Vault root config. What's next after that? Let me clear this one. Yeah, so after this part, the sixth step is that we have to write role. In order to use this credential types or these dynamic secrets, we need to assign roles, vault roles. Okay, so that one user can have a specific accessibility or permissibility. Okay, so let's do that. Let me show you how you can do it. Type in vault write AWS roles. Okay, after this it's your choice, you can put any name you want. So let me put Terraform. Then again, go to the next line, and here you have some options. There are some parameters or arguments. The first one is uh, role ARN. Oh, let me just check, it is role or roles. Let me just check it. I've also listed from Copilot here. Yeah, yes, it's role ARNs. Okay, you can just ask it. I didn't search the documentation. There are other parameters as well, but we will be only needing these two: credential type and the role ARNs. Okay, be very mindful of this as it is role ARNs. Okay, if you miss the as, it won't work. I've faced this multiple times, so yeah, be very careful. And there are some other ones. So for the minimalistic setup, we are only going to do these two because these are the most minimal setup that you will be needing. So again, let's go back. So okay, first one is credential type. So let's type in credential type equals assumed role. Let me again check whether it is assumed role or assumed role. Is there any ed? Yes, ed, assumed role. Be very careful about this because it might get you in trouble. Then you have role ARNs. Again, it's S ARNs equals what? It means you have to go to the ARN that you have created in this step, in this step, in the second step, this role ARN. Okay, so let us go to the documentation again. Sorry, the console again, and go to the roles. As you can see, our Vault demo role. Copy the ARN. Yes, copy it, and again just paste it. Okay, fine. And what else? Do we need anything else? No, we don't need anything else, but if we want, we can add these as well. There are a few options. You can just type in, like for this one, I just type this command. Okay, you can find it in the documentation, but you know, GPTs or copilots do it better. Okay, fine. So yeah, I think I should add this TTL. Okay, yeah, let's do TTL. Now what this TTL means is that TTL equals, let's say, 1 minute, no, let's say 30 seconds. Yeah, what this TTL means is that time to live, since it is a dynamic key or dynamic secret. So every 30 seconds it will rotate the key that we are going to have, like I have mentioned in this. The key or the dynamic key that Terraform would have would shift every 30 seconds. Every 30 seconds it will give new set of credentials. It will work. These credentials will work to get the permissions of this role, power of this role. Okay, as I mentioned earlier. So I think 30 seconds is too less. Let's keep it 1 minute. Okay, fine, and press enter. Hope to see the successful message. Yeah, success. Data written to AWS roles Terraform. Now we can also check it. Let's see. Yeah, we can see the newly created dynamic secrets by read AWS STS Terraform. Let's see if it is worked. I should see a successful. Okay, what's the error? Okay, let me check. Assuming role. Okay, so I think I have to go to the policies again. Let's go to the policy. I guess I have made some blunder here. No matter, let's go. So this is our role. Let's go to trust relationship. Yeah, in the trust relationship I have nothing. I guess I didn't save it, that's why. So again, let's do this one. Assume role is fine. Add a principal. Go to IAM roles. Sorry, I am user. Sorry, I am user. And again, let's go to the user, our Vault demo. Vault demo user was the ARN. This is the ARN. I thought I confirmed it, but as you can see, I forgot to confirm. Add principal. I kept it until this, but I forgot to press this one, update policy. Okay. So another thing is I don't need this one, service. You can keep it if you wish, but we don't need this one. And assume role, yeah. Now it should work. Update policy, fine. So yeah, guys, very careful if you miss something like me. Okay, now it's okay. Now it's okay. As you can see, the principal is getting the user demo. Okay, fine. And if I show you the user as well, it should also have the proper policy. So I already opened it here. Yeah, role is already there. So now it should work. Let's go. Hopefully. Again, let's enter. Hope to see a successful message. So okay guys, I paused a little bit because yeah, our Vault AWS STS, this command worked perfectly, but I also mentioned a TTL. Yeah, but the TTL is still 1 hour, but I mentioned 1 minute, so I had to do a little search, and I found out that there's a bar, and the minimum bar set for this dev mode is 15 minutes, so we can't go below that. Okay, so we inputted 1 minute, that's why it was going for the default one, and the default one is 1 hour, as you can see, 59 minutes and running. Okay, so yeah, But as you can see, it has given me an access key here and it has given me a secret key, but it doesn't match mine. Let me show you. Let's see, where is it? Yeah, so as you can see, the access key is this one. Access key is this one, but here this access key is something new. Okay, similar for the secret key as well, it is not matching this one. So it has dynamically created our access key and secret key, and it has a time to live of 1 hour. So we can't go for 1 minute, but we can go for the minimum possible, that is 15 minutes. So how we can do that? We could have done it in the previous way, I mean in the TTL argument, but we can also do it like this. Vault write AWS, AWS STS, name of the role, the last bit, this bit, the Terraform bit is the role name. Okay, so and after that you can mention the TTL, and for our case we are setting the minimum, that is 15 minutes, and press enter. It should work now. Let's see. Yeah, fine. So as you can see here, the TTL has been updated. Again, what does this TTL, meaning time to live, mean? It means that after 15 minutes, this dynamically created access key and secret key would swap, or not swap, it would rotate. It will create a new one. Okay, it already created a new one because this secret key and the previous command secret key doesn't match. Okay, because we have given a write command, so it has again created. So if I do the read again, let's see what happens now. Yeah, so it is shifting. It is each time I request for a ID, it is shifting or rotating the access key, and these access key are available for only what, 15 minutes, but when I do a new command, it is again going back to the original by default time. Okay, so it's because that I have given the argument here in this, where is it? Yeah, like this, in this right parameter. But if we had given it in the how to show you, let me again go to the assume role. Let me show you this so that you can get cleared of it. I did a bit of research here. Yeah, let me show you. Here you can also see they set up the TTL 16 minutes. So uh, each time you again request for it, it will again go to the default unless you explicitly mention it here. But it won't go to the default if you have set up here, where is it? Yeah, after this. So we had done this credential type and role RNN. After this, if we have mentioned the TTL equals to 15 minutes, then for each of the requests it will still stay 15 minutes and won't go for the default one, that is 1 hour. Clear? Okay, so it was a bit of complexity from my side, but I think if you repeat the video, I think it should be clear to you. So yes, up until now, if I again go to the notebook, we have done we are done with the Vault role. We have created the Vault role, and we have seen that yes, we are creating dynamically new secrets. Okay, we are not giving away the original one, rather we are creating dynamic secrets after a period of time. Okay, after the sixth step, finally we can go for the Terraform part. We have to write the Terraform scripts, and we are going to build a S3 bucket. Okay, so yeah, let's go to the VS Code again. We won't be needing the terminal for now. Let's close this one. And okay, I think I just, yeah, so yeah, okay, so let's create a file called main.tf, and let's create our script. First we need to create a provider. There should be a bit of zoom in, too much zoomed. Yeah, we have two providers for our setup because we're using Vault and we are using AWS. So we are going to be needing two. So first one, let's go for wait provider Vault. First, let's do the Vault one. Okay, and what argument is needed is the address, if I'm not wrong, address, and the address is the uh, export and environment variable that we have found here in this one. Let me show you, where is it? Yeah, this one, this location, HTTP location. If you have click on this one, it should open up the UI. Let's see, I think I haven't shown you this one. So yeah, it should load up the UI for Vault. Yeah, it is loading, and here you go. Okay, so the token is basically the root token, and you can sign in. Let me show you, since I've already logged in here. Where is the root token? uh, Wait, yeah, here it is. This is the root token. It should give me the signing since I'm using, yeah. So here you go, the UI is active and everything regarding, you can find it here, search engines, policies, and everything. You can have a bit of search and exploration here if you wish, but we are using CLI. So yeah, so again, back to the actual stuff, that is the Terraform script, and for the address we have to mention this address. So let's copy and paste it here. Paste. Another thing that we have to mention is that token. The token is the root token here. So again, let's copy the root token, mind the spaces, there are no spaces. Okay, fine, this is done. Now you might wonder or ask that why need this token, why this address? Because we are not doing the authentication, remember, we are not doing the authentication part. So that's why we are providing the root credentials, so that Terraform can first access the uh, Vault. Okay, what I'm saying is that Terraform itself needs to request Vault first. Okay, but in order to request, or in order to get the secret key from Vault, it needs to have a certain authentication. Okay, and since we are not dealing with any other authentication method like app role, as I have previously mentioned, uh, we are not going to do this in this session. Maybe in the future session we are going to provide the root credentials. That's why we have added the root token and the address. Clear? Okay, fine. Next thing is that we need the data or the credential from the Vault itself. That's why we're going to need a block type data, and we're going to need, let's say, uh, I forgot the type, if I'm not wrong, Vault AWS credentials, access credential. Okay, okay, let me just check it if I don't want to make mistake here. I already have it written here, so let me just check. I don't want to make a blunder now. Let's go. I've already written all the commands and all the steps here in my vlog, and yeah, here you go. I can just copy paste it from here directly, but let me, yeah, let's copy paste it. It will save the time. Okay, fine, let's go and copy paste. Okay, so let me zoom in a bit. So what basically what I'm doing here is that I've mentioned this part is that I'm using the authentication, the root token is given, and now I want to have the data. For that, I have to mention the backend, the secret engine, which is AWS, and the uh, the block name, block type. This is Vault AWS access credentials. Yeah, I was doing it correct. Yeah, and I have to mention the role so that Terraform can find the correct role, which is Terraform. I have named it Terraform. And next, I have to mention the provider AWS. uh, since we are using AWS. Okay, we have to mention the region. Okay, and this one is very important. We are getting access key, secret key, and token. Now you might wonder what is token here. Well, when you use STS, what is STS? When you are when you're assuming anything behind the scene, you're using something called AWS STS, which stands for service token, token service. Let me show you again. Let's go. Yeah, AWS STS. Okay, so it stands for AWS security token service. So it provides tokens. So since we are assuming the role, uh, behind the scene we are using STS. Okay, and that's why uh, we are seeing this token or security token, because when we use STS, we interact with this security token. Okay, that's why it is important. Otherwise, if you don't mention this token part, you will get an error. The system or the flow won't run. Okay, clear? Okay, so these two lines are very simple. We are getting the access key and the secret key from the vault itself. And how we are doing it? We are going to the data block here. As you can see, we are going to the data block. Then we are going to the AWS access credential, this type, as you can see, and then we are accessing the Terraform role, as you can see mentioned here, and then it is going into that role and it is getting the access key. I have previously shown you where it is. Again, if I go back, where is it? Okay, it's loading, I guess, but I can do vault read AWS STS Terraform. It should load. Okay, I think it's stuck somewhere, but nonetheless, I've shown you that how it creates the secret keys and the access keys. Okay, so fine. So we are done with this, and after that we are creating a resource, that is AWS S3 bucket, and we're giving the name of the resource. It is not the name mentioned in the S3, sorry, AWS. The name that the bucket would have in the AWS is this one, Vault TF AWS. Okay, so this name and this name are different. Okay, mind this. So yeah, yes, this one also loaded. As you can see, we can have our access key and the secret key, which are getting accessed in this line and this line. Clear? I hope I'm clear. And whenever that Terraform asks for this credential, it also needs has this security token, something called security token, and it also needs that. Clear? Okay, fine. So we have explained the Terraform script as well. Very easy and very simple script. I will provide you the link to the blog I have here for reference. Here, it's a Hashnode blog. I will provide you in the description. So yeah, so we are done with what step? We are done with the AWS part. We are done with the Vault part, and we are done with the Terraform part. So all we are left with is running the Terraform scripts and see whether the entire flow meaning from uh, Terraform asking the Vault for the credentials, from getting it and then using it, to create the infrastructure, that is the S3 buckets. So let's go. First we need to run Terraform init. Done. It is run successfully. Then Terraform plan. See, in the left portion we are having nothing here. So after I run the Terraform plan, you should see some files. You should see the state file, you should see the log file. Sorry, after the apply, since we are using the first command here. No changes, no infrastructure. Oh yeah, this is a very important thing. Very important thing. You know why I'm getting this? Because I didn't save this file. Disclaimer, guys. After you write the script, Control S or go to the file and click this save. If you don't do this, Terraform won't recognize it automatically. Be very careful. Let's again run the init. Okay, I was assuming like, wow, it's the init just ran in 2 seconds, because init should install all the providers. Okay, as you can see, all the providers are getting uploaded here. Okay, all the necessary credentials. Okay, fine. It should take a bit of time installing HashiCorp Vault, installing HashiCorp AWS, as you can see here. Yeah, so let's give it a bit of time. So after a few minutes, it has run successfully. Now for the next command, that is Terraform plan. Okay, and now we should see something. Okay, unlike the previous situation. Yeah. So after a while, unfortunately, I got this error. Okay, so it's very important that you also know this. I forgot one argument. Okay, so in this data uh, block, I have added this type. You know why it's important? Because when, let me show you in the notebook, when Terraform asks Vault for credential and Vault gives it back, Terraform validates those. Okay, let's say if I have IAM user credentials, let's say secret key and access key. Okay, and Terraform now received it from Vault. So Terraform has to validate that whether it's correct or not. Okay, since it has now AWS provider, so it can validate with it. And if there is no IAM user uh, related to these secrets, then it will give you or throw you an error. Or if it can't validate, let's say Terraform doesn't have access to run the validation process, then it will give you error. And this happened in our case because, first of all, Terraform doesn't have the permission to check IAM credential. Okay, whether how many IAM users are there in my account and are they valid or not. It doesn't have that permission. And secondly, in assume role, we don't have any IAM user. We don't have that thing. Okay, instead what we do is we are using session tokens and we are using STS. Okay, so if it still runs the validation, it will result in error because there's no IAM user for it. Okay, that's why in order to resolve this, I had paused a bit so that I can find out what's the problem here, and unfortunately I forgot to mention this argument, that is type STS. Okay, when you mention this argument, Terraform automatically gets that it's assumed role credential type, and it is STS and there's session based tokens. I won't need to validate those. Okay, so it's a must, otherwise you will get this error. And after that, I also ran this so that it saves time, and it ran perfectly. Okay, it ran perfectly. So yeah, and obviously don't forget to save it, guys. Do it manually without Control S if you want, but don't forget to save it. Clear? Okay, so after that it worked fine, so nothing to worry about. And one command remaining, that is Terraform apply. So let's run that one as well. Terraform apply and place enter. It might take a few minutes, so let's wait. So after a few minutes, I again made a typo, so I again ran the command, and after a while I also had to reapprove it, typing the value yes, and we created our S3 bucket, okay, named Vault AWS. Okay, so the moment of truth, let's see whether our Terraform got the credentials from Vault and used it to create infrastructure that is S3 in our AWS account. So let's go. I've already loaded. Let's refresh it. And yeah, and here you go. It is 7:18 and it is showing 16. Okay, as you can see, 2 minutes earlier, okay, since I paused the video. And as you can see, Vault TF-AWS bucket, S3 bucket has been created. So what we achieved is that the the Terraform Terraform went to Vault Terraform went to Vault, and in return it got dynamic credentials. Then it used it to build S3 in my AWS account. Clear? So yeah, so let me give you a summary of the total session today. So we started with the agenda, that what we are going to do today, and we have shown this diagram. Like I've mentioned earlier, we discussed why use Vault, why it is so famous, and we mentioned that we were going to be using dynamic secrets, and we also mentioned that there are 4 types of credentials in a Vault, and we were going to use assume role, and I've mentioned the entire process of how assume role is used, and I've also mentioned that it is used using STS in the background. Okay, fine. And like that we went step by step, and in 7 steps, okay, 7 steps, we finally uh, made the workflow happen, and we got our S3 bucket created in our AWS account. So guys, it was a long session, I know, but I didn't skip the errors that I got. I didn't remove those, so you can learn as well. Okay, so yeah, in the next videos I hope to include app role in the workflow. So until then, stay tuned and hopefully you'll be benefited. Bye bye.